Now let's continue with the same problem, problem number 3 as before. Now we want the total annual cost of the inventory policy. So total annual cost is annual ordering cost plus annual holding cost. Holding cost or carrying cost, they both mean the same thing. So annual ordering cost is D over Q times S plus Q over 2 times H. So that's your annual holding cost. So that is equal to, so remember from problem number 3, D is 360, H is 0.8, S is 100, and Q is 300. So then we get 360 over 300 times 100, okay, plus 300 over 2 times 0.8, and that is equal to 120 plus 120 is 240. Now here, since we did not have to round, we are getting the two costs to be identical. But if we had to round this, then it will not be identical, but it will still be very, very close. And if you get like 120 and 80 or something like that, then you know that there is some kind of mistake somewhere. Okay, next we're going to illustrate the concept of robustness. We talked about robustness of the EOQ formula. So that's what we're going to do in this problem. So assume that the demand was actually higher than estimated. It is 500 units instead of 360. What would be the actual annual cost? And we will also find the difference. So given D is now 500 and not 360 as we originally assumed, and Q is still 300. So we didn't know that it was going to be 500, so we were still ordering at the rate of 300. Then the total cost with Q being equal to 300, so now it's going to be D over Q is now D turned out to be 500. So this is what our ordering cost turned out to be. Then our holding cost will still be the same as before. So our actual cost turned out to be 286.67. Okay. But if we had correctly identified at the beginning of the year that the demand was going to be 500, so for D equal to 500, Q must be, or economic order quantity must have been, we should have used 2 times D times S over 0.8 is 354. We should have been ordering at the rate of 354 and not 300. If we had ordered at the rate of 354, our total cost would have been, okay, of course it's going to be smaller than this. Let's see how much smaller. So D is 500. Now we would have been ordering at the rate of 354. So that's our ordering cost. And then 354 over 2 times 0.8. This gives you 141.26 plus 141.60. See, it is not identical because we had to round here, but still very close. So it is 282.84. See, the difference is really very small, about $2 out of close to $300, even though the demand was significantly higher. From 360 turned out to be 500, and still the change in cost is very marginal. Okay, now let's look at the reorder point, okay, based on constant demand and constant lead time. So the ROP, it's called reorder point, and this is also a quantity. So reorder point is inventory level at which the next order must be placed. So for constant demand and constant lead time, okay, constant demand and constant lead time, ROP is given by D times L, where D is demand rate, L is lead time, and D and L must be in the same units. So if lead time is in weeks, then D must be demand rate per week. The lead time is days, then this should be also demand rate also must be for days. So given D is 3 per day, L is 15 days, ROP is 3 times 15 equal to 45 units.